Hello and welcome to Lecture 4 of Unit 3 for Intro to Logic. We're still talking about translating into polyadic predicate logic. We don't have a lot new to cover today. We're just talking about restrictive clauses. That shouldn't take us too long, but this topic can be extremely complicated and it can be a little intimidating, but hopefully if you just take things one step at a time, you can break things down to a manageable level and then you'll have no problems. So restrictive clauses are phrases that begin with that, which, who, and whom. And those clauses modify usually the subject, the grammatical subject or predicate of a statement to make them more specific. And in that sense, they're a lot like adjectives that modify nouns. So we saw that when you have adjectives modifying nouns, usually the way you translate them is by taking two predicates and applying both predicates to the same variable inside further parentheses joined by and. So if, say, a carrot is an orange vegetable, you say, or all carrots are orange vegetables, you'd say for all x, if x is a carrot, cx, then in parentheses, ox and vx applied to the same variable. But here we've got something very much like an adjective modifying a noun. You've got a that clause modifying a noun. So if I say all rock stars that dance are sexy, that's just like saying all dancing rock stars are sexy. So you take both the predicate being a rock star and the predicate dancing, apply it to the same variable inside further parentheses. So you would say for every value of x, if both in parentheses rx and s and dx, if x is a rock star and x dances, then x is sexy. What makes them a little bit more complicated is that you don't have to just have a single predicate. You have something more complicated. You have something that involves a polyadic predicate. Like if I say, some rock stars that love diddy dance, you're saying there is an x, it's a sum statement, so we use the backward z. There is an x, it's a rock star, rx, and lxd, that means x loves diddy, it's a diddy-loving thing, and it dances. So that the other thing we say about the variable x can be as complicated as you like. So the two examples I've given so far, we've got that clause modifying rock stars. So it's modifying some predicate that you already have there in the English. So that's, you join together the two predicates with and. The only exception to when you join together the two things with and is when you have like a word like everything or something that doesn't already have a predicate in it. Then the that clause takes the place of the predicated otherwise restrict. So if I say everything that loves Fergie dances, that's just like saying every Fergie lover dances. So for all x, if x is a Fergie lover, that is if x loves Fergie, then x dances. So for every value of x, if lxf, then dx. Something that Diddy owns is not a gun. There is something that's a Diddy own thing, and it's not a gun. So there is an x. Diddy owns x, that's O dx, O for owns, D for Diddy, x for the thing. There is an x, Diddy owns x, and x is not a gun, not gx. Now, what really makes these restrictive clauses complicated is when you throw in really complicated logical forms into the restrictive clause, like quantifiers. So if you say something like everything that loves all women loves Fergie, you've got all in the restrictive clause, right? So again, it's going to take the place of the predicate, but you're going to say something more complicated than just a letter and an x, right? You've got to say something like, for every value of x, if x loves all women, then x loves Fergie. So when you're translating something like this, I like to break it down into steps. So you start with the basic form of the statement. So the basic form is one of the four squares of the square of opposition. It's either a universal affirmative, a universal negative, particular affirmative, particular negative. In this case, everything blank is blank. That's a universal affirmative. So we're going to translate it with the upside down A with the arrow. Then I'm going to fill in the parts using some mix of English and logic to break it down into stages. So I'm going to do it in parts. So the first stage, I'm just going to write half in logic, half in English. For all x, if x loves all women, arrow x loves Fergie, where the x loves all women part and the x loves Fergie part are still in English. And then when you translate that part of it, x loves all women, or x loves Fergie, you can just concentrate on that part. And when you're concentrating on that part, you want to treat x in that context as if it were a name, like Diddy. Diddy loves all women. You're treating x as a name. The only exception to treating x as a name is that since you're using x as kind of like a name in that context, you can't also use the variable x. If another variable comes up, you have to use another variable like y. So I'm translating X loves all women and treating X as a name. If I need the variable for all women, I'm going to use Y for that. So X loves all women means the same as all women are loved by X. So for all Y, if Y is a woman, then LXY. X loves Fergie is just LXF. I can take those two pieces now and plug them back in for the English in the original thing. So I get for all X in brackets, if for all Y, WY arrow LXY, then LXF. And that's basically how I translate anything that involves this kind of complicated restrictive clause that involves a quantifier. I would do it in steps. So I have 3 examples here of increasing complexity. The last one is kind of it's almost there just to be silly. I would never give you something like that on an exam, but something like this first one might come up. Some rock stars whom all women love dance. So the main verb of that sentence is dance. So that's what comes after the end. So the basic form of this, again, that's what you want to figure out first. The basic form of this is a particular affirmative, some blank or blank. So you write, there is an X, something about X, ampersand, something about X. And the way you break that is by the main verb, that is the verb that is not in a that clause. The only verb that's not in the that clause is dance. That's where you break it. So that's after the ampersand, you write X dances. And then the whole thing with the restrictive clause comes before the ampersand. X is a rock star whom all women love. Then you can take it in pieces. So X is a rock star, the whom becomes the and, all women love X. So there is an X, RX for X is a rock star, and all women love X. That's step 2. X dances becomes DX. All women love X for all Y, if Y is a woman, then LXY. So you put that all together, you get backwards EX, braces, brackets, RX, and for all Y, in parentheses, WY arrow LXY, and X dances. Some rock stars who own some guns are loved by no women. Again, here we've got 3 quantifiers. We've got 2 sums, we've got no, but the basic form is still some blank or blank. So we're going to start with backwards EX, something about X, ampersand something about X. And what we plug in there is broken up at the main verb of the sentence. The main verb of the sentence is are loved by no women. So we say X is a rock star who owns some guns on the left, write that in English. On the other side, we write X is loved by no women. Then we can take it in pieces. X is a rock star and X owns some guns. You can reword that with the quantifier at the beginning. Some guns are owned by X. You can do that in English still at this point. And again, X is loved by no women. You want to reword that so the no is at the beginning. No women love X. Then you can take it in pieces. X is a rock star becomes RX. Some guns are owned by X. You can leave that for now. And then no women love X for all Y. Y is a woman. That's not the case that Y loves X. And then just the last piece to do is some guns are owned by X. There is a Y. Y is a gun. And X owns Y. So notice I'm using the Y quantifiers when I'm translating things about the internal quantifiers. I'm not going to use X again. Again, I'm treating X as a name in those parts. It's okay to use Y twice, so long as the scope of the quantifiers to go with the Y don't overlap with each other. So you can see the backwards EY there. It ends with the OXY part. That's where the parenthesis that comes after it ends. The for all Y that comes after it is not overlapping with the scope of the backwards EY. So it's okay to use the same variable twice. So if you wanted to use Z for one of them, that's totally okay too. And again, this last example, don't worry about this too much. I just want to show you that if you break things down step by step, even really complicated cases can become manageable. But this is a lot more complicated than anything I put in an exam. But just to show you how the process can be extended to really complicated examples. Every Jabberwock that only outgribes those things that every Bandersnatch outgribes, gimbals no toves that gimbal themselves. That's really complicated. But if we take it in pieces, you can do it. So if you look at the main verb of the sentence, the verb that isn't in a that clause, that's the word gimbals that comes after outgribes. That's where you want to break it from the main form of the statement. Again, this is a universal affirmative, so it's for all X, something about X, arrow, something else about X. So the first thing about X, I'll just write in English. X is a Jabberwock that only outgribes those things that every Bandersnatch outgribes. That arrow, X gimbals no toves that gimbal themselves. Okay. So X is a Jabberwock that, it comes JX and sometimes if the word only occurs, I like to reword it with the only, because the only doesn't generate the same kind of ambiguity as that only does. So if you reword X only outgribes those things that every Bandersnatch outgribes, the only things that X outgribes are things that every Bandersnatch outgribes. That's going to make it a little bit easier. Then on the right of the arrow, X gimbals no toves that gimbal themselves, I want to reword that so the no is at the beginning. No tovs that gimble themselves are gimbled by x. Okay, so now I can do the only. Remember, the only is the same as all. So the only things that x outgrabs, for all y, if x outgrabs y, then every Bandersnatch outgrabs y. Things that every Bandersnatch outgrabs becomes every Bandersnatch outgrabs y. No tovs that gimble themselves, for all y, if y is a tov that gimbles itself. It's not true that y is gimbled by x. That's what the right side becomes. And now I can do these pieces. So x outgrabs y becomes oxy. Every Bandersnatch outgrabs y becomes, for all z, if z is a Bandersnatch, then z outgrabs y. And for all y is a tov that gimbles itself becomes ty and gyy. Remember, gimbles itself is going to be y gimbles y. Y is gimbled by x becomes gxy. Then the last part to do is z is a Bandersnatch becomes bz, and z outgrabs y ozy. You put the pieces together, you get that last thing at step 5 there for every value of x. If jx, so j is x is a Bandersnatch, and for all y, if oxy, then every Bandersnatch outgrabs y. For all z, if z is a Bandersnatch, ozy. Then for all y, if ty and gyy, then not gxy. I wouldn't expect you to be able to do it something that complicated on the exam, but it shows you that if you break things down into steps, even something that seems almost impossible like that is doable. So that's all the new content for today. Starting next time, we'll get into derivations for predicate logic, so don't forget how to do derivations, and I will talk to you soon.